On this episode, guest Richard Anderson, biochemistry expert and author of The Evolution of Life, Big Bang to Space Colonies. On today's Open Highway.
The Open Highway with Eric Erickson.
And hello, everyone. Thanks for joining me on this episode of The Open Highway. I am your host, Eric Erickson, and it is a true pleasure for me to have you join me today. On this episode, my guest is Richard Anderson. He is a biochemistry expert and author of The Evolution of Life, Big Bang to Space Colonies. And we are going to talk about just that, space colonies, moving out into the universe, leaving Earth, how we'll have to evolve, what will change. It's a conversation on a topic that's actually very complex, but Richard does a great job presenting it in ways that we understand. And anyone who listens to the show or knows me knows I am a fan of science fiction. I always have been. And if you read The Torch Universe, the series that I am currently writing, you'll know that it's a theme that weaves its way through the books. The Great Exodus, leaving Earth. So this was a really amazing opportunity, and I am happy to share this interview with you. Here he is, Richard Anderson. So one of the things that jumped out at me as I was reading your bio is you're not only a fan of science, but you're a fan of science fiction. What's your science fiction background? So I mean, what is your world of choice when it comes to the fiction?
It's interesting. I haven't read science fiction for a few years now, but I do have a collection of classics, and the Foundation series. I have, I can't even think of all the titles. Most of it's hard science fiction, but I do like fantasy as well. And it's a place where you can express ideas because you're not constrained by reality. Mm-hmm. So you can, if you're in hard science fiction, then the goal is to stretch your knowledge and see where it could apply. If you're in fantasy, you can explore ideas, social ideas. So one example would be that I really like is Avatar, the movie and the book.
Okay.
Because there's so science fiction a lot of times takes their theme from science. And they did in Avatar with the mother tree when the root system and the communication underground and all that stuff connected all life on that planet. And in a sense, that's what we have here with our mycorrhizae, which is the roots underground from trees and different plants, and the fungal growth underground communicate with one another. And they're synergistic relationships where fungus can digest rock and mineral deposits in the soil and make them available to the root system of the tree. Some root systems will actually, from their leaves, from their photosynthesis, they make sugars. They can actually transport some of those sugars down into the root system to feed the fungus. It absolutely blows your mind. There's this non-brain communication, a chemical communication. Likewise, when you have a forest, say, of conifers, and they're being attacked by beetles, well, the trees that are being attacked release a chemical that alerts other trees around them to produce more sap, because how they get rid of the beetles is the beetles tunnel into the tree, and then the tree responds by producing sap and pushing the beetle out. And then encasing it, which eventually might become amber after it hardens and over eons of time. So the problem with that is during a drought, you don't have, the tree doesn't have the resources, doesn't have enough water to do that. So they're more vulnerable. And we saw that during the last drought, last 10 years or so in Canada and northwestern California, Oregon, Washington, all those areas where you saw swaths of trees that were dying, even the Tahoe Basin in California.
Oh, we've seen a lot of it here. A lot of it. We're seeing changes. We're seeing incredible changes that way because we're even seeing seasons change.
Oh yeah.
Exactly. I'm in Southern California, so I'm in Los Angeles, and like a good example is I suffer from pollen allergies. I suffer from certain sorts of allergies, and we're seeing a shift in when the actual season, the pollen seasons are, and I know that that's a thing, and insects and they're getting pollinated at different times of the year. And these are adjustments that we have to make check this segue out. These are adjustments that we have to make as a society, as human beings, because our environment is changing biologically.
Absolutely. And we're seeing migrations of disease vectors moving into more temperate areas because the temperate areas are becoming subtropical. There's a lot of things like that that are evolving that we need to adjust to. The coral is dying because, well, there's ocean acidification and there's warming water. It doesn't do well with either situation. So basically, when I wrote the book, I wanted to show a strong link with life, the evolution of life, with the evolution of the universe. People say that we are children of stardust, we're made of stardust. Well, that's an incomplete analogy. So I wanted to build a strong, we live on a molecular level. We live on the atomic level. And that was started with the Big Bang. So that's where I started the book. But mainly it's ecological and where we are, what the future of our planet is, what can be done about it, and why it's not being done. And then if we survive as a civilization, where do we go? How do we survive? And if we go into space, what are those parameters?
That's what interests me. I mean, all of it interests me, but I've always been fascinated by the idea of getting off this planet, because there's a lot of scientists who say we are not meant to stay on Earth, as part of our evolution is to move out into the universe, which is something that's been used in a lot of science fiction, that Earth is just a starting point.
Yeah, absolutely.
What do you think about that?
Well, two things. One is we evolved on Earth. Our biology is linked to Earth, to the ecosystems, to the rhythms, to the climates, to the day-night cycle, the circadian rhythms, to the gravity. Our vision is most acute in the wavelengths that the sun produces most of. So we are, and also emotionally, psychologically, we need our force. We need our natural environment. That we came from the savannah, but we also came from forest land, and so if we move into space, we have to. My belief is we have to meet all of those parameters. So presently, NASA and Elon Musk and some other people are they're talking about space, and they're talking about colonizing Mars, and they're talking about a moon base. NASA's planning one for the South Pole of the moon, which is a good idea. But most astroengineers or space engineers don't have a strong background in biology. So they can look at a planet like Mars and they think, well, we could terraform that, and we could, or even if we don't terraform it, we could form permanent colonies there, and we could use that as a second Earth. And I really don't agree. And one reason is it's very inhospitable, and it'd be very difficult to terraform. And terraforming, if we did do it, it would not be permanent because the planet itself cannot sustain an atmosphere, doesn't have a magnetic field, doesn't have enough gravity to maintain an atmosphere, and the magnetic field would deflect the solar wind and the radiation, which otherwise would strip away any atmosphere. So there have been a number of proposals where you could mitigate some of those things, engineering proposals.
Yeah.
The bottom line is you have 1/3 gravity, 1/3. So here's the psychological part. You are never going to have forests on Mars. So basically you're going to be living underground. And you can make huge shopping malls and, parks or whatever underground and power them. But I don't think that's psychologically going to be very satisfactory for long-term, multi-generational living. And you don't, to advertise say you're forming a colony and to attract people to come there and come move to this colony, you get 40 acres and a mule or whatever, and diminish yourself physically because you're going to be living in 1/3 gravity and living here several generations. What will that do to our physique, to our bone density, to our muscularity? Will we ever be able to return to Earth and that sort of thing? Moon is worse because it's 1/6 is the density. So, well, I would say the gravity, it's the size and the density. So you can have bases, and there are a lot of resources on both the moon and Mars that could be exploited. The difference between a colony and a base is, in military terms, a base, you rotate staff on and off. They're not permanent, they're not multi-generational. They serve a term and then they're moved to another venue. So you can have bases, and depending on the effect, we don't really know what the long-term effects of that gravity would be on us. We do know that microgravity has about a year, you're going to lose a lot of bone density. Even with exercising and a lot of countermeasures, you're still going to be weakened. So 1/3 gravity, we don't really know, but I think it would have effect over generations and probably much sooner than that.
Well, that would start to create variations on the species then. That
Right.
would literally, because I know it's going back to science fiction, it's such a wonderful touchstone because somebody's explored it and you can kind of use it as a case study, although it's fictional. But Arthur C. Clarke got into that a bit in 3001. He talks about they create, I believe they're called like space elevators. And basically they create a second around the orbit of Earth. They create another, it's like a ring. And people live up there and they're off Earth. And after generations, they start to have what you're describing. They're starting to have bone density issues and they're not able to visit Earth for very long because there's physical effects. So you're actually creating a divide in the species and creating a new evolutionary shift in human beings.
Yeah, exactly. And I forget who the author was, but there was or the name of the book, but I remember the scenario and exactly what you're describing. And these people developed or were bioengineered, I think, to have hands instead of feet. So they had
what book was that? I remember that. I'm with you. I can't remember what it was.
So you had 4 hands because you don't need feet, right? You're floating around doing things. And it was how they were discriminated against and they couldn't come back to the planet and so forth. But it was an interesting concept. However, our brains are wired, well, from fish. Actually, we walk based on how our fish brain is wired. Fish swim in an undulating motion, and we walk swing an arm forward, the leg goes back. We walk. If you watch a lizard or a salamander scurry, they walk like a fish. They undulate like a fish. Well, that's their wiring. And basically, for tetrapods, and I would consider we're four-limbed, we're tetrapods, horses and so forth, they walk that way, wolves and everything. There's some exceptions. So those kinds of things are tied to our Earth and the way we evolved. And so changing that might not be as easy as it might seem, but I think we would diminish ourselves with less gravity. That's the main concern. And the other concern is we love our natural environment. We decompress when we go to the beach, when we take a swim, when we walk in the forest. We and I don't know exactly why, except it's peaceful, and it's something, you know, if you lived in a apartment all your life and hardly went out except to the restaurant and to the gym, would that be very satisfactory? Well, that's what some of these colonies might be like if they're on Mars or the moon. In outer space, so in the 50s, Dr. O'Neill, what the heck was his first name? I want to say Timothy, but I don't remember offhand. Anyway, he invented a mass driver. You're aware of what that is?
A mass driver? I'm not.
Okay, well, I'll explain that in a minute. But he proposed space colonies, and he proposed either the Taurus wheel, which was in 2001, rotated to create one gravity, or what was called the O'Neill cylinders. And these were like beer cans, only they would be maybe 20 kilometers long and 2 or 3 kilometers in diameter. And they would rotate, and you would live on the inner edge. And you would develop environments that would look very much like Earth. And you would, in his examples, he used mirrors and all kinds of stuff like that to bring sunlight into these cylinders. And you also have to protect yourself from radiation, and that probably isn't practical. But you can put solar panels outside, and you can develop sunlight inside, and you can develop day-night cycles. You can do a whole bunch of things that are very similar to Earth. There are some structural issues that haven't been resolved. But that would, because we're talking multiple generations, and in the 50s, in the 60s and 70s, and I think it was in the 60s, NASA did a study on the resources in our solar system. If we were to develop, you know, what is out there? What can we use? And they studied just the asteroid belt. And they determined there was enough material in the asteroid belt to build the equivalent of 3,000 Earths, surface area of 3,000 Earths. There's plenty of material out there. And they're layered so that the inner asteroids are the denser, heavier elements, nickel, iron, and those sorts of things. And then there's a kind of a regolith, like rock material with high silicon content, and similar to the Earth's crust, a little bit further out. And then further from that, there are asteroids that are almost pure carbon, like coal. And that's because there probably was originally a couple of planets that were large enough to be molten and gravitationally stratified. And then they collided, broke up into the asteroids. And so you have very specific content in different asteroids.
So as we would go out and you have to make this mining part of the process, which is kind of frightening in a way, because it's like, let's compare this to somebody who came to the New World, someone who went on Earth, who went to another place and built a colony 100, 2, 3, 4, 500 years ago, as far back as you want to go. You land on the shores of what is now America, and you go, okay, well, I need to build a house. Well, there's trees everywhere. Oh, I need food. There's food everywhere. It's everything's around you. It's just a matter of getting up and doing it. It's a little different when you go out into space, where it's okay, if we don't find this, we will die immediately, or if something goes wrong, if the air duct goes down, or if this goes down, there's got to be an evolutionary psychological angle to that, of death at every corner.
It's
that's got to affect you.
Yeah, it's not an easy problem, but okay, you would start. Of course, you would start small, and you would supply the initial project. Say you're going to, I talk about the L4, L5 Lagrangian points where orbits are stable, or in L4 and L5 are within the Earth orbit. One precedes and one is behind the Earth, and they go at the same speed. And they're balanced with all of the gravitational forces and the centripetal forces of the orbit and all of that. So they're stable. So you would start your construction, not the Earth sun, but the Earth moon. So it would be closer to the Earth. And then you would have to build a manufacturing facility. Now, the thing about exploiting space or the materials on space, and Moon and Mars, unless we find life on Mars, that's a different story. But you don't have to worry about a ecosystem. You don't have to worry about killing, a species of something. It's inanimate space. So all of our environmental concerns kind of go away. And you can say you could crack asteroids out in the asteroid belt, which is between Mars and Jupiter, and bring pieces of what you want in close to Earth to your construction site, and then you build your first colony, which would be small for engineering purposes, and then you're going to build a manufacturing facility. So you're going to bring all your materials in, and you're also going to catapult materials from the south pole of the moon, if NASA's involved and that's their base. Now, a mass driver is a linear magnetic motor. And the best analogy for that I use in my book is a roller coaster that California Adventure has. And it used to be called California Screamin', and then they reinvented it. I forget the new name. I rode on it when it was California. Okay, so have you ever been there? Or
I haven't. It's been forever since I've been to California Adventure. So
it's a sensation because you're sitting on the track in this roller coaster, typical looking roller coaster, and there's the first hill, which is quite a climb. Well, normally the roller coaster gets on a track and slowly goes up the hill, and then it gains speed as it goes over the crest and comes down the other side. This one accelerates from where you are and shoots you up and over that hill. And it goes from 0 to 55 in about 5 seconds or something. And there's a series of induction motors along the track. So that in a sense is a mass driver. So in my book, I have a picture of one. If you go on the NASA site on your computer, go for pictures, you can sort through. They have all kinds of great pictures. There's a picture in there of a mass driver proposal for the moon. So it's a long track that's magnetically driven. You have a car with a bucket or something that holds whatever you're going to launch. And it accelerates to escape velocity and then releases the load, which you design it to shoot where you want to. And then there's a orbiting satellite, orbiting station that is just timed, so it will pick up whatever. So if you're sending an I-beam that you produce on the moon, then this satellite spaceship would just be there to pick it up.
So isn't this this is like the idea of the rocket sled, right? Where it's
Yeah,
the immediate propulsion and
except it's solar powered.
okay.
We don't have to rely on chemicals because it's
Yeah.
magnetically driven,
Okay.
which makes it highly efficient. And the moon being, basically getting the same sunlight that the Earth does, would have plenty of solar power.
Are we ready for this as a species? Like, you got to wonder. It's like we have a hard time just getting out of bed in the morning sometimes as human beings. I mean, are we ready biologically, psychologically for something? Like if NASA came out tomorrow and said we cracked the code for interstellar travel, we can now start moving out into the universe, we can start building these colonies and bases that we've talked about for years, we figured it out, how to do it financially, how to do it safely. Are we ready for that as a species? Like, do we have the wherewithal to do it? Do we have the mental capacity and the biological capacity to be able to handle that? Or do we need to evolve as a species in order to be able to handle the things that you're talking about?
Well, that's a terrific question, and I deal with that in the end of the book. We are and we aren't. It's we have evolved a dichotomy in our brains based on environmental needs as we were on the savannah, cavemen, and so forth. And I don't want to get too far into that, but basically there are people who are ready and there are people who would totally reject that. The first call, so society as a whole is not. There are some people who probably are. Mm-hmm. So the question becomes, how do you select? First of all, they would have to want to participate, up to the individual. Yeah. And they would have to have a skill set that was compatible with the needs of the mission, mm-hmm. which would be basically would involve all of the sciences, I'm pretty sure. It would also involve all of the social sciences, medical sciences, everything all the best of what we know, because it's going to take all of it to put us together on a. We're not like Apollo 13 astronauts where we can sit in a little capsule for, a week and not move and not.
Yeah.
I can't imagine doing that myself. So, yeah, part of us, some people may be ready. So there would have to be a selective process. And we can't move everybody off of Earth. How many people? We have 7 billion. We're going to have, by the turn of the century, maybe 11 billion mm-hmm. people. And our birth rate is going down globally. It's going down. But because of the large numbers we have, the actual increase is still going on. And that's a major component of our environmental damage. More land committed to farming mm-hmm. practices that are not sustainable, and a lot of things like that.
It's one show that science fiction show that I got into multiple times is Battlestar Galactica. And it's this whole idea of societies living on ships. And it's kind of touches on what you're talking about is this, we have this idea of like, oh, we're going to go out and we're going to find an Earth-like planet and we're going to just like, everything's going to be wonderful. We're going to hand in hand walk into the sunset in this new world. And then on a show like that, it's like, yeah, life ain't that nice. Like you're cramming people into these big metal tin cans, and in that situation, like you brought up an interesting point where we need the best and brightest. We need this idea of everybody serves a purpose toward there's a reason you're here, scientists and social scientists and whatever. But then in a show like that or a situation like that, it's like, okay, well, you were a reporter in the old world. Now you're going to learn how to grow corn in human excrement. It's just this like you may not be doing what you think you're doing on this new world.
That's it. Those societies are going to need reporters. They're going to need politicians, although politicians aren't going to have the power that they do. They won't be able to make decisions on sensitive decisions will be made by scientists, by engineers, by ecologists, by biologists, by psychologists, social scientists. There'll be a lot of talent that will have to be used to, you can't afford to make a mistake. That's my point.
Exactly. Yeah.
And,
Lives are on the line.
But going back to Battlestar Galactica, at least you got a cool uniform to wear.
In the old series, the new one they weren't quite.
Oh yeah. So
but I always liked those jackets as a kid. I was like, oh man, I want one of those. Like, I want Apollo's coat, man. That's really cool.
Oh yeah, that was. So Star Trek was an interesting one because their environment had absolutely no dirt in it, no germs, nothing. You wanted a cup of tea, you got it out of the machine. You wanted a steak, or whatever. And but they did recognize the need to get off the ship, so to speak. So they created the holodeck, and you could make a forest, you could camp out, you could whatever you wanted. And that was an attempt to recognize the need that we do have for those elements. And
there's a psychological part to it. Like, I think that we learned a lot. I mean, this is my opinion, but it's my show. We learned a lot from the pandemic, because we used to have this idea. It was like, oh yeah, we can all live alone and forget people. And suddenly we're like, holy cow, if we don't interact with people, it changes us on a psychological level. And we're seeing those repercussions, especially with children.
Oh, yeah.
But we're definitely, I would hope that scientists, especially space exploration scientists and people working on these problems, would have looked at the pandemic and went, okay, there are case studies in here of what happens when we isolate people, or they only are able to communicate virtually, or they're not able to just go outside.
Yeah, you can't have just engineers like we did with the Apollo program. You need the full spectrum of human capabilities and knowledge. You can't have somebody with a mechanical voice say, Houston, we have a problem. I mean, there's a strong emotional need. And when I was looking at domestication, for example, and there's a large communication capability that is body language. And one of the major things that attract the attraction between a dog and a person, the dog has learned to read our body language and respond to it. And one of the evolutionary things that happened was we have a white sclera in our eyes. Apes, chimps do not have a white sclera. And so the dog can actually see where you're looking you're looking somewhere without turning your head. Okay.
Oh, okay. All right.
And so they can read your body language. And when you have a face mask on, that interrupts part of the communication. And as between kids, are they smiling? I mean, I checked out of the supermarket and I'm trying to be friendly with the person, and I realize I'm smiling behind my mask, and it's not there.
They have no idea. Although I have found as I get older, I do get the smile wrinkle line, so people can start to tell that.
There's a little.
I guess it's the one good thing about getting older.
Yeah, there's a little.
How do we move forward on this? With what's the path that you see? Because there are definite changes. I pose the idea of like, hey, if NASA suddenly came up and said, guess what, we can travel, we figured it out. We're not ready for that. But what needs to change? Are there biological changes or psychological changes or ways that we look at the world? What do you see having to evolve before we're able to handle that?
Well, first of all, I think we need to get back to the moon, start establishing a base. The same with Mars. And a foothold there. Now, Mars is going to be difficult to support. It's so far away. You're talking months and months to get there. it depends on the positions, but say there's an emergency and the Earth and Mars are not in a good position, you could be 2 years trying to get there, or you have
That's
to.
the Martian. That's the whole idea of the Martian is like he's screwed. He's got to go make potatoes until they show up.
Which, by the way, wouldn't have worked, but that's another story. So
That's a whole other show.
I think once you have a base on, just say the moon, it's going to happen on the moon first,
Mm-hmm.
where people start to see this as a permanent thing, then all of a sudden you have a capability in and your escape velocity for launching from a moon base is much, much easier than from the Earth gravity well.
Mm-hmm.
So that would be the first thing. And you do have the resources on the moon, and you have the resources on Mars. So Mars is a more interesting place because there is the possibility of life, and there may be the possibility of it still being alive, it's still being viable. And I say that because we know there are lava tubes and on Mars and from its past, and those are ideal places to start to build your base and your I was going to say colony, but the place where you would live while you're on Mars, not a permanent presence, but long term, fairly long term.
Yeah.
A year or two, I think, before you'd be rotated off. One of the problems I see with the present proposals is there is no accounting for, that I'm aware of, for providing artificial gravity on the trip to Mars. The moon, it doesn't matter because it's a few days. Mars, by the time astronauts in microgravity arrived on Mars, they would be in a pretty highly weakened state. Mm-hmm. And then you expect them to go through a landing on Mars with a 1% atmosphere, where that landing on Mars is so much more difficult than landing on the moon because its gravitational field is stronger and because its atmosphere isn't going to give you much resistance. You have these massive chutes, and then NASA has used retro rockets and all kinds of things to land their landers. So you're coming in at a high speed, and you have to use a lot of power to get yourself down to a safe landing.
So we have these. Sorry, you brought up something really interesting. I want to point out is how long is the journey to Mars?
Well, it depends on the positions, but it's going to be, say, 7 months at the shortest.
Okay, so we're talking. I mean, 7 months at the shortest, 7 months to a year, depending on. Let's just, for the sake of the discussion, we have this weird, through science fiction and other things. We have this. It's like the scenes from 2001 where he's like running. Oh, and yeah. They're exercising on the wheel, basically on the hamster wheel. I mean, is that viable to keep the physical up? And then we have the other idea of like, oh, we'll put them in cryogenic sleep for 6 months. I mean, are those even potentially viable?
Cryogenic, that's an interesting idea because you would, of course, you reduce your biosupport needs, but I'm not
You're
sure.
Still deteriorating as a muscle and everything.
Yeah. I mean, we're not bears. They don't
which don't even really hibernate like we think they do. But
I mean, they don't really deteriorate. Bears have evolved in their own way. Yeah. So yeah, maybe we could eventually get that there, but I think we'll solve the other problem first, is how to maintain your gravity and how to maintain
your muscle.
Because you're on interstellar flights, for example, you would have to contain a biosphere. You would have to be totally self-sufficient. And so you take one of these cylinders that Dr. O'Neill designed, and you put rockets on the end, and the thing still rotates. And then it flies in the direction of the cylinder is, wherever you're going, and you can go forever. Well, now you need solar power, so maybe we would have developed hydrogen fusion by then. That would be a power source that would take us multi-generations, we could float around and pick and choose where we wanted to go and what planet, if we find any planets. We'll get into the planet part later, but
do you think part of solving that part of the equation, who's behind that? Because I think there's two camps, both in reality and fiction, is like who makes the decisions. We kind of touched on it with the politicians jokingly a few minutes ago, but there's the idea of, okay, well, this should be run by scientists, and they should be making the decisions because they're the ones that know best as far as the science goes. And then there's another argument that it always seems like the military is behind something like this because they know how to do a beachhead, they know how to set up a base, they know how to like get stuff, for lack of it, sorry, but they know how to get shit done. Is just kind of the way it comes down to. But those each come with their unique problems.
Yeah. Well, just going to Mars, the simple trip to Mars. One proposal was you would have a long spaceship, which would be perhaps a rocket body, and then you would put the life pods on either end, and you would tumble it to create one gravity, and this thing would be flipping through space toward Mars. Not any science fiction source has ever shown anything like that. So it's not in people's radar. Yeah. And that would maintain your gravity and your physique, hopefully. What was shown on 2001, what was the spaceship name? I forget, but anyway, the part that rotated independently of the ship.
Yeah, it's like,
well, that's complicated. It's better to rotate the whole ship. You don't have to, what happened if you saw, what was it, 2006? There was a subsequent movie that
2010. Yeah, where they go to Jupiter.
Yeah, and the rotating component had frozen up and the whole ship was tumbling, which was kind of fun, but the bearings had frozen up or whatever. Yeah. And so they reestablished the rotation and the ship corrected and all of that. But that's complicated because you've got two bodies moving in different directions. And if the whole ship rotates, there's no reason why it wouldn't. And then you have a circumference area where you're creating one gravity, where people spend most of their time on a long voyage. Remember, the asteroids are out there between Jupiter and Mars. So the trip to the asteroids, you'd have to almost establish base out there
to kind of hop jump. Yeah, refilling or emergency places.
These things, a lot of them are very large, and they may be something you want. You might want to break them up out there and bring smaller pieces in. Can you imagine, a 6-mile diameter asteroid, nickel iron asteroid that you're trying to maneuver into a L5 or L4 position and Earth Moon position, and not hit Earth? You got the big gravity well there, and everybody on Earth is like, God, I hope they don't screw up on their trajectory. And what kind of motors would it take? There's a lot of inertia, with a big object like that. So you would have to have, a presence in the asteroid belt to take advantage of that. The other problem on Mars is two problems. One is it's about 56% of the Earth's, the sunlight that hits Earth hits Mars. So you've got a reduction right there in solar efficiency. The second thing is the Martian dust and the storms, which can be planet-wide and can last for months. So you need a nuclear presence. You need plutonium reactors or something to provide power. You can't rely on this. Well, if your solar power dies, if your power dies, you're dead. You're growing plants with grow lights. Basically, you're taking a page out of the Northern California pot growers, that grow in containers underground.
Maybe they're the ones that need to run the mission to Mars.
And maybe a little prop would help out up there.
Make those 7 months go a little quicker.
Don't have a heart, but you have magic mushrooms. Oh, so that's there are some obstacles. And I don't see the gravitational one or the rotational one being addressed by NASA or by SpaceX. They haven't said anything about it.
We really did kind of like we kind of stopped the momentum on the whole. I remember growing up, in the 80s, it was like, oh, yep, next stop, the moon. We're going to set up a base. We're going to set up this. And then everything just kind of came to a screeching halt. And then when it got brought up in the last 10 years, people are like,
well,
whatever.
There's the other argument. We have so many problems on Earth. Why do we want to spend all the resources to go to outer space and to set up colonies and to do any of this stuff? And my answer to that is one of the greatest engineering collaborations ever on the planet Earth was NASA during Apollo 13, where they brought their whole team working on one problem, one objective to find solutions and bring these guys home. And they had if you study that, they had a sequence of problems. Each one was terminal. And they knew once, well, we solved this one, we got another one that's even bigger. Yeah. So in fact, they corrected the trajectory to come back to Earth to speed them up because they were going to run out of oxygen. They solved the CO2 atmosphere problem with the scrubbers from the command module. But then they weren't going to have enough oxygen. They would asphyxiate before they landed, like 2 days or a day before. So they had to adjust their trajectory. Yeah. So that the team with a focused project like that, well, with space colonies, you're not going to have a very complex ecology. You're going to have a balanced ecology that will support all the animal life, the atmosphere, the food cycle. All of this stuff has to be carefully calculated. But you can mimic many different venues on Earth. So you can have different colony structures that mimic maybe a tropical island environment, maybe an alpine environment. You could have some containers that would be ocean, like a big terrarium, not terrarium, aquarium. So that you can mimic these things, and it would take teams of scientists to design them.
Are you talking on the
on the colony side?
On the actual colony once on the actual planet, on Mars or whatever planet? Or are you talking the trip to
floating in space? They have to solve these. Well, on Mars as well, because they're going to have ecosystems there. So you're going to assemble engineers. You're going to assemble biologists, ecologists, all kinds of skills to develop these ecosystems and monitoring systems to make sure they're always in balance. And then, of course, if they get out of balance, your engineering would be able to tweak temporarily, if your atmosphere is off or whatever, until the biologist, because biology is a slower process. You can do something engineering wise immediately, but biology takes the time to evolve.
But you're still stuck in these like self-contained ecosystems.
But what I'm saying is you develop expert teams, and each colony has a separate team working in a separate kind of environment that then can focus on Earth problems because they're by necessity, they're supported. Here you have a government that's fickle. They may support the space program for a while, then politicians decide they want to do something else. And to have a concerted effort like we had in the early days of NASA, you would have that in space colonies because they would have to do it to survive.
So what you're saying is, so I just want to make sure I'm clear on this. So they may have an ecosystem. They may create, let's say they create a bubble city, for lack of a better, I just, in my head, I have this image like the old 1950s sci-fi with the globe and the, they can see the Mars sky, but inside it's all trees or something. So if they said, okay, well, this one, this is our new Amazon, and they're like, we are going to just look into the problems with how the rainforest and trees cycle carbon dioxide or something like that. That's their problem solving, and they work on it for a little while, and then suddenly they go eureka, and they call back to Earth, and it takes 27 hours for the message to get back because it's millions of miles away. And they go, guess what, we figured out the problem. Here's the code, here's like whatever, implement this, or whatever the scientific discovery is. It could be used to really tackle specific problems
on Earth.
It's sort of like my girlfriend's father was a research scientist, a scholar, and one of the things that he did is he studied. I just found this out recently. He worked with some of the insects that were taken up into space, and then they looked at the reaction of cosmic rays, to use my comic book geekiness, but how that affected. But it was a specific study. It was a specific, like you're saying, a problem solving. Let's take our mental energy and put them into this.
Right. And some of that's been done on the space station, with plants, with insects, with bacteria, with why do some organisms resist radiation, freezing, and different things like that. So that's been the first step.
Okay. There has to be a New Vegas, though, on Mars. There has to be, I mean, we can have the tree one, we can have the aquarium one, but there has to be a gambling one, because that's just, every good sci-fi has that,
Well, all bets are off if we find viable life on Mars. It's going to open up a whole quagmire. How do we protect, especially if it's not the same code as, if it doesn't have the same genesis as Earth life. It could have.
Yeah.
Even one genesis, in fact, start on Mars and then ended up on Earth. There's that.
Yeah.
But
do you get into the psychological, philosophical side of it, or do you try to remain more in the biological, hard science, or do you allow yourself to kind of explore that?
I'm not an expert or a very knowledgeable about psychology or anything, but there is a link between. I have a chapter in my book called "The Structure of Our Thinking." Mm-hmm. I show a diagram of the brain, and I show where different things are located, and how different behaviors are based in structures in our brain, and how all human brains are built pretty much the same way. So if you're thinking about a beach scene, and I'm thinking about a beach scene or sand, it's hitting the same areas of both of our brains, which is it's understandable, but it's also amazing.
Mm-hmm. It is.
So they have discovered, I shouldn't say discovered, the research isn't done, but there are indications with some research that, for example, psychopaths have a deficiency in the connection between the amygdala and the prefrontal lobes of the brain. So the prefrontal and the frontal lobes you have a reptilian response to something. You have a need, you're going to get it. Mm-hmm. Well, the prefrontal and the frontal lobes come back and say, wait a minute, there's consequences to that action. You may get the immediate reward, and then the next step is something really bad is going to happen as a result. The psychopath does not have, in some very limited studies, pilot studies, they've determined through conscious CT scanning of the brain, mm-hmm. that they have a diminished connection between the amygdala and the prefrontal and frontal lobes. So they don't have that check on their actions. And I use an example of the movie Fargo. Mm-hmm. Did you see that movie?
Oh, I remember that one well, yeah.
Okay.
Are there going to be wood chippers on Mars? Is that the issue that we're going to?
Yes, yeah. The thing is I forget the actor's name, but when he's got the guy's wife captive, and she's got a thing over her head, and she's sitting in a chair, and he's watching his daytime TV show, and she's whimpering, and he tells her to shut up, and she keeps whimpering. So he has a problem. She's interrupting his TV show. He pulls out his gun and shoots her, and then continues to watch his TV show. So that would be an extreme example of a psychopath. He has no awareness, concern about consequences. His immediate problem is she's making noise. She won't shut up voluntarily. So this is, I'll shoot her.
Yeah.
And I use that as an example because it's so visual. But yeah, so we get into psychology through the structure of the brain, the differences between the way men and women think, for example, the sexual orientation spectrum. Okay, there's male and there's female, and there's a connection, and there's a full spectrum of connection between the two. I don't know all of the ramifications, but that's just the way our brains are made. And so we talk a little bit about epigenetic formation. We have genetic, which is the director, and we have epigenetics, which is the way your development as a fetus and person unfolds, and the result of various environmental impacts. The thalidomide, for example, had a major impact at a critical time in a fetus's development and interrupted the epigenetic expression of their DNA, and they were born with all kinds of deformities and lacking limbs and stuff. So that's a hard example, but it shows the concept that these factors come into play. So psychology and neurology are coming together in a way that computers and mathematicians and scientists came together.
Are we ready for that? Do you think so? So let me ask you that. Let's personalize this a little bit for you. Are you optimistic that humans can handle the changes or the needed evolution on different scales, based upon, like, thalidomide's an interesting way to look at it, because we had something that were forced on a certain part of the population, and we saw this response to it, and not only did how those people respond, but how we responded as a society to them. We made flipper baby jokes for years, and they were cruel, and they were this, that wasn't our brightest hour,
No. But that's a broad brush to paint. The society as a general, there's a continuum of an astonishing continuum of awareness in the human species, from the very amoeba type to the brilliant. So as a society as a whole, I would say again, certain components of society are. I think the way we approach this is through medicine, as we're improving someone's life. If we're improving their physical life, like has been done with the boy who was homozygous for sickle cell disease, so he had both parents, so he was going to die at 20 or so, left to natural causes. They actually used a new technology called CRISPR, where they could, and it happens that disease is a point mutation. It's one substitution. Most of them, like cystic fibrosis, are 50 or 60 different mutations that all contribute to the genetic disease. In that case, it's a point mutation. So they could excise. They took his bone marrow, a sample. They changed the DNA. They removed the substitution and put the correct nucleotide in its place. Grew him in a petri dish or whatever, and re-injected him. So now he has his own faulty red cells, but a large portion of them now are normal. So they won't have a crisis like a homozygous. He'll lead life like heterozygous, which is almost normal life. So that's the first actual DNA change to treat a genetic disorder. So if you approach it from that standpoint, we're going to correct, this disease, Tay-Sachs in the Jewish community, or some other that have evolved in sequestered populations. Then I think it's acceptable that people see the benefit. And now you're going to put people into space. So how do you select them? Well, part of it would be, if you had the knowledge, you would do mental mapping. There is a project called the Connectome, which is like the Human Genome Project, only it's the brain. Much more complicated project. And it's to try and figure out what the code is, what the programming is, what makes us tick. And the difficulty there is our brain is plastic, so it's always changing.
But the idea is that if we send someone into space or somebody to colonize, they're best suited for. We're trying to find the best, not the best and brightest, but the best suited for
psychologically, socially,
Yeah, but that will change, like you said. That'll change. Like, we can't chart everything.
Right. So hopefully by the time this, and I give it a time scale of 100 to 200 years before we're building colonies. We'll have basis and presence. But before we get into these colony things, I think it's going to be quite a while. Hopefully we'll have the tools to first be able to screen people, and those tools will come from medicine, correcting issues with faulty issues with people. This boy that was given his DNA was modified. That was semantic, whatever. I can't think of the word. DNA or cell. It wasn't a germ cell. So nobody's proposing making changes to the germ cells until we really know what we're doing.
Yeah,
because that goes on to the next generation.
That's dangerous. There's a whole discussion in that. I mean, but that's a situation where we get to Mars, to use that example, and suddenly there could be changes and diseases, or there's external influences that we might not even be taking into account at this point. I joke about cosmic rays and Fantastic Four, and suddenly we all have superpowers, but there could be something that affects human beings in a way that we have not even taken into account yet.
Right.
So what you're saying is you have the DNA, that if you're able to have this DNA, if you're able to have this way of fixing it, that might be what we have to do, and be like, oh, well, this radiation affected him in this way, and now he has this cancer or this tumor or blood, whatever. And then we're like, okay, well, now we have this DNA tech we've worked on for a while. We can fix that on a molecular DNA level versus just pumping them full of drugs or something.
Yeah, I think the protection from radiation, a lot of that research was done on the space station. And I think that we've pretty much gotten all that solved. So I don't think that's going to be the issue we have as far as mutation, ongoing mutation. We have a natural mutation that occurs just in our replication. So I talked about epigenetic expression. When the fetus is growing, it starts with a zygote, fertilization zygote, and then it goes through its development process into a fetus. And the offspring they almost can predict how many mutations they have, point mutations, where their DNA is not from either, where that mutation is not from either parent. It's because of quantum mechanics. There's a certain amount of probability involved. So there are going to be errors. Most of them are benign. They have no effect. As well, you'll have a fatal error and the fetus is aborted. Or you have a genetic disease that has somehow crept into a population and then is propagated, usually in a recessive sense. and only becomes dangerous when it's homozygous. Sickle cell is a good example of heterozygous sickle cell partially protects against malaria, so it was kept, that mutation was kept within the population in malarial areas. So we won't have that we won't have malaria up there, you know, but we will have ongoing just random mutations.
And we're going to have to deal with.
Yeah, so we'll have to deal with that.
So let me, we have a little bit of time left, and I'd love to, there's two things I want to do. First question is, if NASA called up tomorrow and said, "Hey, Richard, we want to bring you into a meeting, and we want your thoughts," what would be, and briefly, like, what would be your initial things where you say, "Okay, you need to work on this, this, and this. So these are what I think you're not taking advantage of, or this is where the direction I don't think you're paying attention to." What would you say to them? What would you bring to that meeting and say, "Hey, grab your shoe, bang it on the table, and said, you need to hear this"?
Well, actually, they do have some pretty good plans for the Mars base. They're going to bring some photosynthesizing cyanobacteria up there in these little canisters that will produce oxygen. And as a means of sustaining an oxygen environment, or oxygen in their environment, in their enclosed habitats. They have a design for a test hydroponic greenhouse. It will be the first one looks like it'll be underground, but if you go on their site and look, they have a diagram of one of these glass dome type of things, you know, with all the plants underneath. They may get to that. The big issue that I have with them is they haven't talked about how they're going to maintain artificial gravity. They have the Artemis program. There's been no indication that they've addressed that issue at all. And I think it's a major one for when, the reason I stated, when you arrive in a weakened state. Now, you've seen Scott Kelly when he was brought back from the space station after being up there for about a year. He was carried off in a stretcher. Well, and they have exercise equipment, so they do mitigate some of the issues. But and he did recover pretty quickly. But so my thing about the bases on the moon and on Mars is you will have space stations or colonies offsite that provide the gravity. So they spend a stint of time on the surface, and then they go back up into orbit into this rotating whatever structure, and live there and exercise and regain their strength. And medicine will have to figure out what the time intervals are to maintain our optimal health and all of that. So I think that's the major thing that I haven't seen them address. They're looking at
we see it in science fiction. It's always just a switch on the wall. Artificial gravity on, artificial gravity off, and turns into a comic scene. So I think it's interesting.
Yeah.
It's interesting.
One of the Star Trek episodes, they lost their gravity and they're floating around.
Yeah. Oh, so the blood's like floating around in that's from the movie. So let's take a minute now that we're wrapping up. Tell me a little bit of, let's tell the audience a little bit about your book and where they can get it. And now is your self-promotion. Self-promotion. Pump everybody. Okay. And there'll be links in the show notes to everything. So everybody can click on that as well.
It's called The Evolution of Life, Big Bang to Space Colonies. And I start with the Big Bang to show how matter evolved, how chemicals evolved, how the periodic table expresses all of the possible chemical elements in the universe. So we can't go to some far off place and everything is different. It's all the same. So if there's life, well, getting ahead of myself, if we look at the periodic table and we see that life on Earth is all carbon-based. So is it so throughout the universe? And my position is it's the only possibility. Carbon-based molecules, different kinds of molecules are in the millions, perhaps almost infinite. The next competing element, silicon, has been proposed, and it's because of the structure of the element, and the orbitals are at a higher elevation, so to speak. They're further from the nucleus. They're not held as tightly. Cannot form these long chain molecules that carbon can. The bonds are much weaker. Mm-hmm. So silicons that you buy, for your kitchen and whatnot, they're made by alternating silicon bound to oxygen bound to silicon. It's an alternating chain with methyl groups attached to the silicon along the way, and they make these rubber-like compounds. Pure silicon is like a metal. It's brittle. It's like a rock. So life is the same in the sense that it's carbon-based wherever it exists in the universe. And there are limited places where it can exist. So there are pockets within the certain distance from the center of galaxies, and not all galaxies are able to potentially support life. We get into evolution and cataclysmic events and the effects on evolution, and we look at life, it effects on itself, how that affected evolution, synergism and parasitism, and the different mutualism, the different relationships between living organisms and how they affected the course of evolution. I mentioned the cyanobacteria as a photosynthetic bacteria that produces oxygen. That created a huge extinction on Earth in an ice age, a global ice age. They call it snowball Earth because it overwhelmed an anaerobic atmosphere and removed a lot of methane from the atmosphere that was a greenhouse gas. And you remember you have to know back at that time, the sun had about 30% less output than it does today. So we talk about the evolution of the sun and how that is played into this. And the biggie in my mind is the uniqueness of Earth, and that its density is out of proportion to its position in its orbit around the sun. It is even more dense than Mercury, which should be the most dense planet. So Mercury is denser than Venus. Earth is much more dense, or it's denser than Venus, but also Mercury. The moon is much less dense than Mars is, so it's out of whack. And
all this is in the book, and this
anyway,
that's a lot. It's like, but it's all accessible the way that you approach it, right? Like it's not
the average reader who doesn't want to get into the weeds of a lot of detail can get the concept of what I'm talking about. And I use a lot of charts and diagrams. I use a lot of pictures from NASA and from NIH and so forth.
It feels like something that's worthwhile, though. It feels like something, like, even if you have to like read it over, it really feels like something that people will find interesting, and it's important, because if this is our next step, we should understand what's going down.
I think what I wanted to do was to impart an understanding of how connected we are to the universe, to our own planet, and how there may not be a duplicate in the universe. And we're not going to go anywhere in the universe. Just talk about our galaxy. It's 100,000 light years across in diameter. So we're not going to zip around our galaxy anytime soon. So we have to value our planet, because, to go find another place, even if it's Mars, it's not going to work very well.
Yeah. That's the conceit of Interstellar, is this idea, they're literally spending years. His daughter gets old because he's out there trying, and that we didn't even give into the idea of relativity. And I mean, that's like an 8-hour show. But yeah, like we all think, oh yeah, we'll just jump in our spaceship and we'll, like, it's Star Wars, we'll just zip over to the next planet. And Take a couple hours with a wormhole.
Here's the cool thing: if you have space colonies out there, it won't be very hard to travel between them. And like I said, you could have different venues. You could have parks. You could have resort ones, where you vacation, and you hop in your spaceship. You don't have to use much energy to get there because there's no gravitational field. You just calculate your trajectory and away you go. And you spend your 2-week or month vacation, or you change jobs or venues or whatever. So you could create a whole society in space. Now, there's another question I don't really discuss in the book, but, well, I do a little bit. The various countries, China, US, Russia's kind of out of the play, but other countries are looking at assets on the moon and Mars and in space and so forth. So you have countries that want to control different parts of different things and aspects in space. If you develop space colonies that are self-sufficient and interdependent, they kind of hold the high ground, not only in knowledge, but in position. And they don't need Earth, but Earth might need them for resources. So you do, I think there is some real possibility for the future if we ever get to that point.
If we can get there, yeah. So final question. Star Wars or Star Trek? I think I know, but
Star Trek.
I knew it.
This is a space cowboy movie. I love it. I like the Star Wars series more than Star Trek. And Star Trek used a lot of mechanisms to actually they were established early on, for production costs. The transporter room was, they didn't want to have to show these shuttles going out to the surface of planets all the time, so they developed a transporter, and that's way out there. You can do one phase of it. You can deconstruct the person.
Well, there's a philosoph. I've seen it too. There's a philosophical argument. It's the idea of when you build the boat, if you replace every bit of the boat, at what point does it stop becoming the boat that it was originally and become a replacement? And that's the idea with the transporter is like, well, is it really the same person that you would like get away from the whole idea of the soul? But there is the idea of if you're breaking something down and then rebuilding it, is it still the same person that you just transported from point A to point B, because it's not the same particles, and that there's that whole argument there.
Well, are we anyway? By the time we're adults, we replaced almost all of our cells, and
that's a whole other show. I know I'm not. I'm like lifetimes ago.
We have 30 trillion, I made this mistake, 30 trillion cells in our bodies with our own DNA, and 33 trillion cells in our body that are microbes. So what are we?
Some days I don't know, like Mondays. I'm like, I don't know who I am. Oh, I'm going to wrap it up here. I have to, but I really appreciate the time that you spent with me. I really have been looking forward to this interview and talking. This is a subject I could talk for hours, and I really appreciate you putting up with some of my probably pedestrian questions.
Support comes from the History's Trainwrecks podcast that focuses on stories like a temper tantrum that changed history, the president who promised not to run again and regretted it for the rest of his life, the World War II general who lost his pants on a secret mission in enemy territory. The History's Trainwrecks podcast, available now.
Hey everyone, I hope you enjoyed the show. I'd like to invite you to check out the show notes for more information on our guest and links to their books, as well as links to the Torch Universe series, available exclusively from Kindle Vella. It is a shared literary universe, and it is unlike anything you've ever read. So please like, subscribe, and share the show with your friends. But most of all, thanks for listening.
For the highways of America, which for so many years were an assortment of as many designs and pavements as there were states, are now becoming one big road that can take you anywhere faster, safer, and more directly than ever before. What is this big road? Where is it going? How much has been built? How much is yet to come? These are questions we ask. Certainly traveling the entire system would be a memorable experience, but few of us have the time for such a trip.